welcome to my lounge. You're the editor-in-chief of Entropy, is that right?
Yep, that's correct. I'm the editor-in-chief of the journal Entropy, and I'm an associate professor of physics at the University at Albany in New York. And I've been a professor here for 16 years, and my research has mostly focused on exoplanet detection and characterization. So exoplanets are planets orbiting other stars. And I have worked mainly on that. I also do some work in theoretical physics on foundations of physics and quantum mechanics. And that's pretty much where my research has been in the last 10 years. And before coming to UAlbany, I was a research scientist at NASA Ames Research Center in California. I was with the Intelligent Systems Division and worked to design machine learning algorithms to analyze data from missions like the Hubble Space Telescope. We studied planetary nebulae, which are clouds of gas surrounding old stars. And I also worked on data from the Earth observing satellites, like the GOES network and things like this. So.
Oh, thank you. Yeah, so I understand that you have been working with Lego. You've been working on a project with Lego, so playing with Lego. Can you explain a little bit about what you were using Lego for?
Yeah, some of that started when I was at NASA Ames. I didn't work with the Legos at NASA Ames. I was working to develop a mathematics for quantifying questions, the degree to which one question answers another. So we're used to Boolean logic, where we can talk about the probability that one logical statement implies another, and this is what we do with probability theory. But I wanted to work with questions because I wanted to design machines that could figure out which questions to ask. So as a scientist, we can think of an experiment as a question. You're asking a question of nature. And so the goal there was to design intelligent instruments that you program them with a goal rather than telling them to do specific things. And then they decide what experiments to do to answer the research question that you have. And that's what I was working on. So I had developed some of that mathematics when I was at NASA Ames and continued to develop it when I got to UAlbany. It's very closely related to information theory, which isn't surprising, and entropy. And I then started a project to actually make robots to perform experiments based on some of this theoretical ideas about questions. And so to do that, I didn't have a robotics lab. As you start in a university, you usually get some startup money. To start a robotics lab, it's going to require, $30,000 to $50,000 of, equipment and a large amount of space. And I thought, well, I don't need big sturdy machines, robots. I could just use Legos, and that would be, I can get enough Legos for $500. And so I did that. That was interesting, working with the university, trying to get, when I started spending my research funds on Legos and having to talk with some of the administrators about, you get a call from administrator, wait a minute, you just bought like 50 Lego sets, or $500 worth of Legos. Can you explain what you're doing? And so once I explained that, it was fine, but that was kind of fun. And while we were doing that, I had started a robotics company with a colleague of mine. We were developing software for this Julian Center, and we started a robotics company called Autonomous Explorations. And we wrote and were granted a NASA grant, a grant from NASA to develop a vision-based navigation system for robots in lunar exploration. and our prototype was made of Legos. And I have to say that I I was very pleased to say that be able to say that I got money from NASA to build Lego robots. I mean, of course, we weren't. That wasn't the purpose. Wasn't to build the Lego robots. It was to test the software. But we made a very good point. You know, we could be asking for $50,000 more to build big metal robots and collaborate with other people, or we can do this for $500. And the NASA people, you know, the NASA reviewers were, you know, agreed that, well, you're testing software. You don't need a giant robot to do this. So, but we built a Lego rover that's probably it's about 3 feet long, about a meter long, half a meter high, and it was designed with it has the same rocker bogie suspension system that the Mars rovers have. And so I actually have this in my office at the university, but it's all made of Legos and can climb up hills and do all sorts of crazy things. And so we basically controlled that with a computer and tested our software that way.
Oh, that's
so I have to say I always thought it was a lot of fun to be able to write a NASA proposal where you propose to use Legos and then actually get that funded. And now actually I've got funding to study UFOs. So it's almost like a challenge. What crazy thing can I come up with next and get funding for to study?
So funding for UFOs. But before that, your career in physics practice was pretty diverse.
Right. When I was a graduate student, I was looking for a project that had something to do with nonlinear dynamics or chaos theory, which you may have heard of.
Mm-hmm. Yes.
And that was I was in graduate school in the late 1980s and early 1990s, and that was a big thing then. You may remember Jeff Goldblum's character from Jurassic Park. He was a mathematician and he talked about chaos theory. You know, this was a big thing. Yeah. And of course, I was very excited about that too and thought this is very interesting. So this is something I want to do. And I had worked with an electrical engineer. We were studying cardiac dynamics, so the dynamics of heart arrhythmias and things like this. And that was interesting. And there must be something wrong with me because I somehow decided this isn't hard enough. I want to do something crazier. So I started studying brain dynamics, and that's the work I did for my PhD research had to do with looking at brain responses to auditory stimuli. And I used magnetoencephalography to study that. So magnetoencephalography at the time was just developing, and you measured very small magnetic fields created by neurons firing in the brain. So when you have a collective group of several thousand neurons firing synchronously, you get a large enough electric current flow that creates a magnetic field that you can actually pick up outside the head. Okay. And so I used that to study brain activity.
Right.
And then once I got my PhD, I went to Louisiana State University Medical Center and went to a hearing research institute, and because I was studying auditory activity. And so I worked there for a while and did some work in designing and doing simulations of cochlear implants and things like this.
Okay.
And then I went to Albert Einstein College of Medicine, where I continued to do more work with EEG and mostly mathematical work on separating brain signals, developing machine learning algorithms to separate brain signals recorded from EEG. And it was really those mathematical techniques that I was developing there that connected me with people later on at NASA Ames, and that's how I ended up moving to the Intelligent Systems Division.
Okay, so yeah, the next question I wanted to ask you, that you did work with NASA in the early 2000s. And right. So NASA Ames, tell me more about what sort of research they do and what you were part of.
Oh, sure. Yeah, some of that was fun because it was kind of an accident. I had a good friend of mine, her name was Allie, from graduate school. and she is an astrophysicist, and she was married to an astronomer who was at the Naval Observatory in Washington, D.C. And there was a neuroscience conference at Washington, D.C. that I was presenting at. So I stayed with them during this conference. And her husband, Arsène, was working on designing what's called a Fourier transform spectrometer. And so he was designing this new instrument to very sensitively measure the light coming off of, coming from stars. He was trying to detect Doppler shifts from the stars wobbling, which would indicate planets orbiting around these stars. So this was related to exoplanet work. And and that night he came home from the lab, and he was frustrated because he had his equipment working, but he was trying to get the computer programs working to analyze his data, and he was having problems with that. And it turned out it was very similar to the algorithms that I was using in neuroscience. And so he talked about his problems at dinner, and I said, well, I think you can do it. You can solve it this way. So we sat down and worked it out after dinner, and he ran upstairs to the computer and programmed it in. And by 10:30, he had the code working and was actually able to analyze data from his instrument. So we eventually wrote a paper on this together and published that. And he then invited me to, he was looking at planetary nebula and invited me to come with him to Kitt Peak Observatory in Tucson when he was working on the 3-meter telescope there. So I went observing with him at that telescope. And then later, when his son was born, he couldn't go on another observing run. That one was at Cerro Tololo in Chile. And since by that time he had trained me how to do this, he sent me to Chile to collect the data with Bruce Ballack and Stacy Powell and a couple other astronomers, which was great fun. Great fun to have a free trip to Chile and do some work at the telescope there. And that's really how I got thrust back into astronomy out of physics. I've always been interested in astronomy, but my research, took me into neuroscience instead. And so it was around that time, and that's the time I was at the Nathan Klein Institute doing brain imaging. And it was around that time that I had heard of the position opening up at NASA Ames in the Intelligent Systems Division. So I thought, well, let's apply and see what happens. And I did. And my career took a sharp 90-degree turn.
Okay.
And so when I was at NASA, I did spend a lot of my time working on developing 3-dimensional models of planetary nebulae. So planetary nebula is a cloud of gas surrounding an old star. You probably have seen pictures of the Ring Nebula. That's one of the most famous ones.
Yep.
And working with my friend Arsène, he had time on the Hubble Space Telescope, and he would take images of these nebulae about 5 years apart. And so you could actually see the size change. You could see these things getting larger as the gas is expanding away from the star. So we were using spectra to get information about the Doppler shift on how fast it's expanding towards you and moving away from you, and comparing that to the tangential size change that you get from the Hubble images. And we were using both together to make 3-dimensional models of what these clouds of gas look like. And the benefit there was it really allows you to calculate how big the cloud of gas is and how far away it is from us. And we don't really have good distance markers in our galaxy. Once you get out beyond 1,000 parsecs or so, you can't use parallax anymore, which is what we use to determine distances for closer objects. And within the galaxy, you can't use the Hubble expansion of the universe. So that's how we get distances to distant galaxies. So there really isn't a good way to know where things are in our galaxy once you get out some distance. And so we were hoping to use these things as distance markers.
Okay, so I was going to ask you about your work with exoplanets, and I think you've answered that. Do you know much about how wormholes work?
Wormholes, yeah. Well, I mean, I learned about them in graduate school when I took my courses in graduate general relativity, and I had the pleasure of seeing Kip Thorne. Kip Thorne came to visit our university at one point and gave a talk on wormholes, which was great fun and
Wasn't
interesting.
he the consultant for that film?
For Interstellar, yeah,
Yeah,
yeah.
fantastic. Yeah.
Yeah, so I've met him and had a nice lecture about wormholes from him as well. So basically, the idea is that you you can have two regions of space that are connected together. So if you move into this area here, you basically come out of this area here, and it's best seen if you. It's hard to imagine in 3 dimensions. You'd actually need another dimension to show how they're connected. But if you took a sheet of paper or something, see, I have plenty of paper here. So if you took a sheet of paper here, and then I actually drew a circle here, and then had this circle connect to another circle here, then you could basically go in here and pop out on the other side. And that's basically what the idea of a wormhole. Now, the problem is that you have to, it turns out that if you were to start with a configuration like this, then Einstein's equations show you that the wormhole would rapidly collapse, basically collapse at about the speed of light, and you'd never be able to get anything through. So that's part of the problems with having a real wormhole.
Okay.
Now, you can keep it open if you have what's called a negative energy density. So if you have something that has negative energy rather than positive energy, you theoretically could keep it open. And the difficulty is that doesn't really exist. We don't know of any examples of negative energy density. It's not quite true. There's an effect called the Casimir effect, which is a quantum effect between plates when you pull plates apart, and you can get a small negative energy density that way, but it's not large enough to be able to use for a wormhole. So there are some practical issues there.
You're talking about plates. What kind of plates are you pulling apart?
Like metal plates.
Metal
So if you
plates,
have
yeah.
metal plates, yeah, you can. So microscopic in that region there, you can actually get a quantum effect that gives you a negative energy density, but it's not sufficient to hold a wormhole open or anything like that. So we don't know really how to create a wormhole. We theoretically, they could exist if you had access to a sufficient amount of negative energy, which we don't. So
in popular culture, we have got the series on the History Channel, the Skinwalker Ranch, with Travis Taylor, an astrophysicist. Is this somebody that you know? And what can you tell me? Can you throw some light on what is happening with the mysterious goings on at Skinwalker?
Yeah, I know Travis, and yeah, I met him before he started working on the ranch. So I haven't talked to him personally since. So I don't know any personal details. There's some really strange things that they've been finding in this location. So, and it appears that there are things that they call portals that they've seen, that the previous owners have seen. Well, right now the ranch is owned by Brendan Fugel, but it was owned by Bob Bigelow before that, and he had the NIDS team there studying things on the ranch with Hal Puthoff and Colonel John Alexander and others, and they witnessed things that looked like portals as well. So these things have been observed there, and it's really not clear. It's not clear what they are, and and so are they wormholes like we would expect in general relativity? That's still an open question, and I don't know what types of measurements they've taken, you know, around these things at the times that they've appeared, it doesn't appear that it from what I've seen watching the show, which is I know what everybody else knows, these things just pop in. It's like, hey, look over there, and then it's gone, right? So it's not really a situation where you don't have something set open for a long enough time that you can set up equipment around it and take some interesting measurements. But it would be interesting to see what they have been able to measure and see what, you know, maybe get some ideas of what these things might be.
I wonder if a paper is going to be written about what they've discovered, because I guess we're getting very simple.
Yeah, I would hope that they collect some solid scientific data on some phenomena and actually publish these as scientific papers. That would be really interesting. And at the very least, you know, publish some kind of, you know, written documents about what they've observed and what they were able to learn about them.
So you first came to my attention through your slide presentation on the star drive report on Professor Jack Sarfati's blog, Jack Sarfati being another physicist with a very long career. You presented an if-then scenario of how travellers from a society that had developed the means to travel at an extreme relativistic velocity could function. The closer one travels to the speed of light, the further one travels into the future of the planet they've departed from. In other words, interstellar travel is essentially one-way travel. You can't go back home. And if these interstellar travelers are flesh and blood, biological, emotional beings, please explain how this is a significant issue.
Those are good questions. It's been long known now since Einstein's special relativity that the faster you travel, the slower time will pass for the traveler, basically. So there's two ways to look at what's happening. You can have, so imagine that we have Earth here, and I leave Earth and I head off at a very, very high speed. People on Earth or elsewhere in the galaxy, when looking at me traveling, if they can see through the windows of my spaceship and look at my clock, they'll see the clock moving very slowly. So time is moving very slowly for me. And they also see my length. The length of the spaceship gets squished. So there's some very real effects that happen here. Now, of course, the same effects happen for, you know, relative to me as the traveler. I look out my window and I see everybody's clocks also moving slowly, and I see the lengths in the direction that I'm traveling are also squished. So distances between me and where I'm heading actually become compressed. So let's say I fly to the nearest star, Proxima Centauri, which is a little over 3 light years or so away, 4 light years away. And so if I'm moving close to the speed of light, it will take me a little more than 4 years to get there. For everybody on Earth and everybody in Proxima Centauri, they'll see about 4 years pass as I'm traveling close to the speed of light and getting to the star system. However, when they see my clocks, depending on how fast I'm going, they'll see my clock moving much, much slower. So if you're going fast enough, you could drive that time down to maybe, let's say 4 weeks. So for me, it's a 4-week trip. 4 weeks pass, and for everybody else, it's a 4-year trip. Now, from my perspective, what I see happening, I don't see my time going any slower. What I do see is that the distance between Proxima Centauri and our sun gets squished. So I'm traveling fast enough that now I don't have as far to go. And so it's pretty quick for me to get there. I can do it in 4 weeks instead of 4 years. So that's basically the perspective. And the problem with this, so it's been long known that this is theoretically possible. There are huge, enormous engineering challenges here. The amounts of energy required to get up to those speeds is incredibly high. The fact that you're going to be flying, you're flying toward a star, so the starlight's going to be Doppler shifted into the gamma ray radiation, so you now have radiation issues. You're going to be hitting, space is not empty. You've got something like a hydrogen atom per cubic meter, so I'm basically flying into a cloud of hydrogen, and especially when the distance gets compressed, all that hydrogen gets compressed. So I've got a wall of hydrogen I'm flying through at close to the speed of light, which is going to tear your ship apart. So there's real issues there, but theoretically you could do it. Now, the problem is that even though it's a 4-week trip for me, if I go to Proxima Centauri and then turn around and come home, for everybody else back on Earth, that would have been over 8 years. So while I can do it in 8 weeks, for everybody else, it'll be 8 years later. So my daughter would be very upset because she watched Interstellar with us a couple weeks ago, and she's still she does not want me to go into space. And I'd signed up for the Dear Moon. There's the Dear Moon contest to see if you can get a free trip to the moon. And she was very upset when she found out I signed up for that. So an interstellar trip would be horrible because, for me, I'm going to be away for 2 months. For her, it would be 8 years. And that's unthinkable. So it doesn't work. You can't, our sci-fi is science fiction is constructed so that your heroes can fly from one planet to another and turn around and come home in time for dinner, right? And
which means they'd be having to travel backwards in time, really.
Yeah, so that's not going to work. So you've had many physicists have said, well, theoretically you could do it, but no one would because it would take you too long. So, so you wouldn't go to, so let's say you want to go to the star Betelgeuse in Orion, right? Which is, I don't know how far is that, maybe 400, is it 400 light years or 900? Maybe Rigel's 900, trying to remember. So it's a couple hundred light years away. So even if I could go fast enough and turn it into a couple-week trip, it's going to take a couple hundred years for me to get there. And then coming back is going to be a couple hundred more years. So when I come back, you're going to be looking at 800 years in the future. And so at those speeds, space travel becomes like time travel. You just are traveling fast into the future. You're traveling through space, but you're also traveling into the future. Traveling in the future is easy to do. You just go fast and come back. And but you can't go backwards in time. Going backwards in time is trickier. That, like the wormhole problem, also requires a negative energy density to pull off. So there's some other challenges there. So we don't know how to go backwards in time. Now, so physicists, while they've known that interstellar travel would work this way, the statement's just always been made that why would anyone do it? No sane civilization would send someone off on an 800-year trip, because the people who are alive now will never get to see the results of the trip. So, so in some ways that it's a little short-sighted, and it speaks to how short-sighted humans are, right? We don't do things for humans 1,000 years from now. We do things for humans next week. And that's really what we do as a race, which is kind of sad, especially now when we have climate change issues, and we don't even want to acknowledge them. But, who knows what, you have people who are willing to say, I don't care what it's going to be like 200 years from now. I'm not going to be here. But that's very short-sighted and selfish, and that's a human thing.
Is this why we are getting in the media, where whenever a journalist wants to talk to someone about the possibility of alien life visiting Earth, that the astrophysicists that are called on to comment are very skeptical and debunking, such as Neil deGrasse Tyson and the Australian article that I sent you yesterday that we looked at. he was this, I can't remember the fellow's name, who's saying, yes, great, we can examine UFOs and UAPs, but they likely have a prosaic explanation because it's just impossible for anybody, any kind of being, to travel across the universe. And why would they come to Earth anyway? Because why travel across the universe and come to such an uninteresting place? What is your comment to that?
Oh, that's good. So yeah, let me finish with the relativistic speed issues.
Okay, sorry.
And then I can segue into that, because there is a society like ours probably wouldn't do something like that.
Mm.
However, you could imagine a radically different society, and for us it's radically different. However, societies like this exist. If you had a nomadic society, a society of travelers, they don't live on a planet, they travel. They travel from planet to planet. Now, a society like that, then traveling interstellar distances at relativistic speeds would be just fine, because I could say, all right, I'm going to go off to this star system. It's 200 light years away this way, and I'll be back in 3 weeks, my time, which will be 400 years from now, right? So, and then you may say, oh, all right, that's fine. Well, I'll meet you back here in 400 years then. I'm going to go head off in that direction and go explore over there. So that would be perfectly fine. We both head off at very high speeds and then come back. And if we time everything right, we'll come back at about the same time and we can basically meet up again. So now you can imagine you could have a whole society like this, where you have a whole society of nomads that just explore and go get resources from other worlds. And they have many meetup points, and you could actually arrange it so that meetup times happen in a predictable way. So you've got a network of meetup points, and you would have a whole society of, I call them space-time nomads. They're not just nomads in space, but they're also nomads in time. And if this were the case, then you would have, that society would be very different from ours, in a lot of ways. First, there's no point in making friends with the locals, we living here on Earth being the locals, because the next time those individuals come back in their spacecraft, it's going to be a couple hundred years from now, and we're not going to be here. No point in landing on the White House lawn, which is something people love to bring up. Americans love to bring that up. There's many levels of ignorance in that type of statement, starting with this Americentric view that the President of the United States somehow speaks for everybody. The President of the United States doesn't speak for half of the Americans, so I don't know why you would land on the White House lawn. And then, of course, why landing on the White House lawn would be incredibly dangerous. I'd challenge anybody who thinks that's a good idea to actually try that. And see what happens. Any intelligent race who's been keeping track of what goes on here would not attempt something like this, because it would be horrible. It would be a very provoking event.
They did the flyby in the 1950s.
They did that's right. And what
obviously happened, they decided against landing.
There was a lot of panic. There was a lot of panic because of that too. So instead of saying why don't they land on the White House lawn, it'd be better for people to ask questions. Where do they land? They land in schoolyards. That's one place that they have landed rather regularly. I think there's a number of events. I mean, you have your own event in Australia. The Ariel School in Zimbabwe is another famous event. But if you were a relativistic nomadic traveler like this, there's no point in landing anywhere and getting to know anyone, because you're not going to be, you can't make friends, because you head off again and you'll come back and it'll be hundreds of years later. It would also give you a really interesting perspective of biology, because you could conceivably study evolution this way. I mean, if you traveled from one side of the galaxy to the other and came back again, that you're looking at about an 80,000 year time difference. And if you accelerate it at 100 G, 100 times the acceleration of gravity, which is on the low end of what we've actually observed with UFOs, so this is possibly reasonable, then if you accelerate halfway and decelerate the other half, you can get to the other side of the galaxy in about 3 weeks. 3 weeks, the traveler's time. It's going to be 80,000 years or so for us. And so by the time the travelers come back, it'll be a 6-week trip. And and you'll have something like 160,000 years will have passed. And so now you can imagine biologists could just do this over and over and over again. And for them, it's a couple years, to make many of these trips. And, over the course of a 50-year lifespan, you can see something like 12 million years of evolution happen on a planet. And so biology would be a whole different, you're looking at things at different scales. So it would be a whole different perspective they would have in those cases.
I just want to jump in quickly. We were chatting before about Dr. Bruce Cornett, a geologist who was studying the Hudson Valley incident, the Hudson Valley flap in the late 80s, early 90s. And he located some exotic materials in a region there, in a mountainous region in Mount Eve. And you were saying that he believes from the data he's collected that quite possibly there are remnants of such alien civilization left there at the 300 million year point. 300 million years ago. Is that what you were saying before?
Yeah, something like that. I've only read a little bit of what he's written, and that was one of his hypotheses, that maybe there was a interesting spaceship crashed there or something a very long time ago.
But there certainly was a lot of
hypotheses. Yeah,
a lot of activity witnessed by thousands of locals of UAPs, UFOs, triangles. Even beings walking in and out of the forest, I understand. I haven't read he's written a book, and an author, a musician, he spoke about, Ellen Crystal wrote a book about that incident, which I'd quite like to read. So, and that's in your area, that's near where you live.
Yeah, that's only an hour drive from here, so hour and a half perhaps, yeah.
Anyway, continue what you were saying.
No, that's fine, yeah. And so there is so even if you traveled at relativistic speeds, you could pull off interstellar travel, but your society would have to be different, that's all.
And you've done some modeling on this, Kevin, on the different civilizations.
I've done some modeling on colonization and the basically simulated many civilizations, each with different parameters, each with different technological capabilities. So in those simulations, I didn't consider faster than light travel because I saw that as less reasonable than relativistic travel. Although you could easily do those simulations as well, but what I was able to find I've done several million simulations at this point, and in those simulations I keep track of which societies find Earth, and you can then do statistics on what those societies were like, what capabilities were necessary, or what situations were necessary to be able to find Earth. And there's some things you can actually learn from these simulations, which was interesting. The most probable origin for this extraterrestrial civilization that's going about colonizing planets would have been no greater than about 20,000 light years from here. 20,000 light years is really long, huge distance, of course, but it's small compared to the size of the galaxy. So galaxy, you're talking about 100,000 light years across. So they come from, so if Earth is, if somebody has discovered Earth, they probably are from not more than 20,000 light years away. So you can figure that out. It turns out it's very hard to find Earth. There's a lot of places to look. It's a big galaxy with lots of stars. So that turns out to be the hardest problem. And the other interesting thing is that the societies that did find Earth in my simulations really found Earth quite a long time ago. They would have to be very old civilizations, several millions of years old, and they would have, on average, found Earth about 2.5 million years ago.
Mm.
So you could have an interesting situation where if we have extraterrestrials visiting Earth, it might not be visitation so much as it was that our solar system or Earth had been colonized. And if that were the case, it probably happened about 2.5 million years ago. So if you have extraterrestrials on Earth today, they've probably been here for a very, very long time, probably
So
longer than our history.
At least 2.5 million, maybe more even.
Maybe more, yeah. That's what the simulations show on average. So if they're here, they've been here a long time, and that's very likely. Now that leads to some other surprising results, because going along with that what that means is that their interstellar domain, their region of space that they control or occupy in our galaxy, that puts Earth in the middle of it, well within the middle. We're not on the edge. The probability that you're going to be right on the edge of their domain is small. It's more likely if they've discovered you, you're in the middle. And so what does that mean? It means that from their perspective, their domain is the region that they own, and they could really have the opinion that they own Earth. And if you think about it that way, that's a very different situation again. Why are they not making friends with us? Well, maybe they don't want us to know we're around, where they want us, keep us, right now where everybody's been getting along because we've not been interacting. Humans don't play well with others. We don't play well with other humans. So, and they're going to be well aware, having been here a while and watching us and grow and develop, they're going to be well aware of that. So, so that could be part of the reason why they don't make contact. And then some of the other difficulties are that they really could have a very different attitude of the situation, where from their perspective, Earth is their planet. We just happen to live here. It's kind of like, if you have a garden in the backyard, that's your garden, and the worms happen to live there, right? But you own them too. They're just part of what's there.
We are clearly the worms.
What?
We are clearly the worms.
Yeah, well, so if that's the situation that we're looking at, or if this ever turns out to be, what's happened at any point, this is going to be hard for all of us to accept, even among people who are, who say, oh, I'm fine if there's aliens visiting Earth. Well, it might not be visitation. They may live here, or they may own Earth, or, have a base nearby or something, and Earth is their planet.
This makes a lot of sense, whereby in the last 70 years, when this has been examined in the modern time, where those that are in the position to have examined this very closely, like the military, the Navy, the Air Force, in the US particularly, are declaring, oh, but it's not a threat. This to me makes sense that,
right.
Well, then it's not a threat because we're just the worms in the backyard. We're not really a threat to them. They come in and look on us every so often, especially when we're exploding big things like nuclear bombs. But yeah, because I guess especially since the Senate report has been released, that we've examined these anomalous objects, and some of them have prosaic explanations and others really don't, and they're showing an advanced intelligent control, in advanced propulsion, but yeah, so the ufologists, I guess, is scratching their head saying, well, why don't you consider this to be a threat? Why has the narrative always been, it isn't, oh, we know they're there, but it's not a threat. So I guess what you're saying totally explains that. It sort of answers that question.
It may turn out that there are some people who've known about this for a long time, and they've been here for a long time. And the idea is like, they've been here and haven't done anything to us, and we haven't, it's all fine. Everything's cool. And that really could be the situation. So there's there's several hypothetical situations where, and of course, these are all hypothetical, where you could have interstellar travelers and they could be here on Earth. You probably, if you have them, if they're visiting, then you probably have something like, unless they have faster than light travel, which I would be surprised at, then you probably have a situation where they're nomadic or something like this, and they've been visiting for a long time. But what we see instead is when there is an event. So missile tests are cases where, these things will show up during missile tests, or the Russians have noted when they have large naval maneuvers, these things will show up during naval maneuvers. That response time is very quick. You're really talking about response times on the order of days. So if you don't have faster than light travel, that means they're not coming from more than a couple light days away, which means they're already in the solar system. And this has led me to ask, or on Earth, yeah.
Well,
and that's led me to ask questions like I've spoken to Lou Elizondo about this, and I asked him, I said, how many craft are present on Earth at any given time? Does anyone know? And he said that that's just not known. But at this point, I would think that they have to be relatively numerous. What do I mean by numerous? Well, I don't exactly know. I would guess probably on the order of 100 to 1,000 at least. And where are they hiding out? Well, that's a good question. The French Cometa report brought up the point that there could be bases in the asteroid belt and we would never know about them. That's very true. The other thing to keep in mind is our planet is very poorly named. We call it Earth. It's a water planet. 70 some percent of the surface is water. It really should be called water. That's what this planet should be called. And we really don't have access to much of the water-covered surface. So it's possible that these things are hanging out in our oceans. And that tracks well with the naval sightings. Why do navies see these things? Well, because they're hanging out in the oceans. The Russian navies have encountered them. We hear more about Russian naval reports than we do Russian Air Force reports, and the same thing in the United States. So it's very possible. So if you're going to try to come up with hypotheses on what's going on, then one relatively reasonable one would be that the Earth could have been colonized a long time ago. You have a number of these people living here on Earth, and they hang out in our oceans. And maybe they're aquatic by nature, and maybe that's a great place for them to live. Oceans from one planet to another are going to be very similar to each other, because the temperature range of an ocean, of a water ocean, is going to be the same on any planet, because if you have liquid water, you're within 0 to 100 degrees centigrade. So the temperature ranges are similar. That's not true in an atmosphere. So for those of us who live on a surface in an atmosphere, every planet's very different. So you go to Mars, and Mars is about 100 degrees colder, 100 degrees Fahrenheit colder, and a much lower air pressure, 1/100th the air pressure here on Earth. So you need a pressure suit. You go to Venus, and now you're talking about temperatures on the order of 800 degrees Fahrenheit and the atmospheric pressure is 100 times more than the air pressure here. So we wouldn't survive that either. And but if you look at the temperature ranges of water, so you've got a water ocean here on Earth. It's wide open, easy access. You can compare that to the water ocean under the ice on Europa. So you've got probably about 20 kilometers thick layer of ice on Jupiter's moon Europa, with a saltwater ocean underneath that is probably has a depth on the order of 60 miles. So if you then look at the gravity of Europa is much smaller, it's closer to our moon, 1/6 of the gravitational force that you have on Earth. Basically, the bottom of our ocean, about 5 miles down on our ocean, that water pressure is going to be about the same as about something like 20 miles down in Europa's ocean. So going from one water world to another water world isn't that different, whereas going from one surface with an atmosphere to another surface with an atmosphere is very different. So if you're aquatic by nature and used to living in oceans, then easy to go. Earth is a great planet, a great planet to hang out on. We have a wide open ocean, and that ocean is going to be very similar in temperature and pressure to any other ocean you're used to. The only real differences and concerns would probably be trace chemicals. So if there are chemicals that are poisonous to you, that would be a problem, or biological organisms that could be, bacteria or whatever that could be harmful. So those would be the only remaining issues.
I guess if these beings have been here for such a long time, these are problems also that have been overcome, because they would have had the time to solve the problems of harmful biological or chemical entities or problems. So yeah, that would be not probably an issue.
So I think because of the rapid response times suggest that these things aren't visiting. These things are here, and these aren't visitations. I think that's an important point to get across. We're not being visited by aliens. If these are extraterrestrial, they're not visiting. They're here.
So really, they may as well be considered part of us. And it's I guess it's our awareness that is changing rather than the situation. The situation is the same and has been since before our emergence on Earth, evolution-wise. But it's interesting. What is fascinating too, I don't know whether you have any comment on this, is that many people who have had encounters with these craft or beings have reports of telepathic communication or strange paranormal activity that follows them, that they start experiencing. Their lives change remarkably. As a scientist, do you have any comment on what could be going on here?
Those stories are the strangest aspects of the phenomena, and I really they are the ones that are hardest for me to believe, and I probably in the past would just dismiss them. Yeah, that's gotta be nonsense. However, I think that now that I've really spent time and effort looking into this, I have to acknowledge that this is what people report, and these people are reporting this worldwide. It's it's not just people reporting this from cultures in Africa or Nepal, everywhere, that and some of which going back far enough that there wasn't internet communication, there wasn't television where this was some kind of mythology that was thrust on them and they adopted. These things were independently reported in many cases, and you have to acknowledge that at some point. The fact is that we've known about the phenomena for about 75 years now. Scientists have refused to study it. We've been told it's nonsense by our governments, and And we've been told the same from scientists. And I've heard that my whole life growing up. This is nonsense. It's silly. These are crazy people. They're nutters, you know, but the problem is the fact that it hasn't been carefully studied has left a vacuum where that has been filled with pseudoscience, because it's being investigated by people who aren't trained to do scientific investigations that, you know, that we're used to, where we have all the controls in place to make sure things are progressing rationally. And I think that's a problem. I mean, the fact that scientists really dropped the ball on this is a big issue. And that's one reason why I became interested in studying this despite the taboo. And now we're left in this really bizarre situation, and it really is the fault of scientists not studying this, that where the only people who know anything about these things are the people who have experienced them. And of course, you have what we would call an extremely low signal to noise ratio, where most, and like you've heard we talked about this, the astronomer in the article you mentioned, and others, most UFOs have prosaic explanations. That's true. It really, you know, definitely true. It really is on the order of about 3% of the cases are what you would call unexplained or interesting. I've seen many photos of UFOs, and my favorite is when somebody sends me, and I don't mean to, I don't want to disparage anyone, of course, but I get a photo of, you know, a light in the sky, and somebody asks me what it is. I don't have an answer for that. My only response is it's a photograph of a light. I can't tell you what the light's attached to. I have no idea. And so you have that. That's very common. And or I've seen photographs of I'm a bird watcher. I've been bird watching since I was 5 years old, you know, with my father. And so I love when I travel, I bird watch. That's one of my favorite things to do. And I've seen many photos of UFOs that I look at it and say, that's a seagull. It's not, it's a seagull at a weird angle. And that I have a few examples that I use in talks of this. Yeah.
Not photos collected by sophisticated military equipment.
No, that's different. Those are not, those are really honestly not seagulls. I know that that's been claimed in some cases. My favorite one is the Go Fast video. There's a lot of criticism about that video, that it's not going that fast. That's fine. That's what they called the video. I don't think that anybody estimated the speed. You can't estimate the speed of the thing because you don't know how big it is and you don't know how far away it is. And there's all sorts of parallax motion going on. The video's called that because it looks like it's going fast. What I think people fail to realize about the more recently released naval videos is that these videos are not entirely interesting by themselves. In fact, I would wager that when these were selected to be released, that they picked some of the most boring videos they have of UFOs and released them. They're really not that fantastic. Now, of course, I was excited to see them and I was like, wow, that's cool, you know, but there's not much data that I'm going to be able to extract from those videos. And I suspect that was done on purpose. Now, the Go Fast, what's important about the videos, the really key point that people don't seem to realize, the media loves the videos because they love showing things, right? It's on television. So here's a visual thing of a UFO. So yeah, the media loves UFOs, great. But the important point about these videos is that these videos corroborate the accounts of the pilots. They act as corroboration as to what the pilots claimed happened. And that's what's important about the videos. They're corroborating evidence. They're not the evidence by themselves.
You were saying in another interview, you have made an excellent interview with Martin Willis, and I think it was in that one that you were saying that the craft themselves are difficult to photograph because we have debunkers and skeptics that say, oh, why do we always have blurry images of UFOs? Why are they always so blurry? We've got so much sophisticated equipment these days. Why we can't believe that these are real because the images are always blurry. Now, you had an excellent explanation for that.
Right. Well, there's a few explanations. One first, most people are really horrible at taking photographs. My father's an artist, my brother's an artist, and so I come up from a family of artists and scientists, and yeah, most people are horrible at taking photographs. And I don't know how many times you've seen photographs of somebody, you know, and it looks like this, right? Oh, they're saying, and they're showing you their vacation photos, and it looks like, come on, you can't put the person in the middle. That's weird, you know. So most people are not expert at taking photographs. That's number one. Number two is you see something weird and you get excited. Most people forget to take photographs, forget you have a camera, or forget to do it, or remember right at the last minute, and it's all horribly. When I pull out my phone, I've got to go through the stupid screen and figure out where the camera button is. And meanwhile, you're trying to look at I do this with birds, right? Because I'm a bird watcher, and if I'm in a foreign country where I'm not familiar with all the birds, I try to photograph them before they fly away so that I can identify them later. So I'm doing this with birds all of the time. Most of my bird pictures are horribly blurry. I can share some of them with you if you want, but they're not very interesting. And so those are two main things. Most camera phones. I'm sorry.
I'll just jump in there, but I remember in the days of working in media advertising, we would hire specialists that there would be photographers that would be specialists in moving images. So taking photographs of racing cars or airplanes, you'd have to get a super specialist in, and they would take thousands of pictures just to get that right picture.
That's exactly
very difficult to capture a moving image. Yeah.
I have my 400 millimeter lens, which is like this, right? It looks like I'm compensating for something. And you know, you have to hold on to this, and you just take a million photos.
That's it.
And 5 of them turn out nice, and that's really about the best you can do. I've done that at I grew up in Wisconsin, and in Oshkosh, Wisconsin, they have the Experimental Aircraft Association fly-in, where they have airplanes, you know, from history and World War II and World War I even, and modern airplanes. And they also have experimental airplanes, which is a lot of fun. And I've gone there taking photos, and that's exactly that's how professional photographers do it. You take a ton of photos, and a handful turn out great. That's how it works.
That is something that you were expecting to see, and you know it's going to turn up, so you can prepare yourself.
That you were ready for. That's when you were supposedly ready for it, and you have the best equipment.
But you're never ready for a UFO. You never know when it's going to turn up. And the fact that we even capture images of them when they're unexpected is a miracle, I think. And they fly faster than anything that we have. So anyway, you have
there's multiple challenges, and so the response I've had when people have seriously asked me this, I've given them a challenge. I've said, look, you have 24 hours to send me a photograph that you've taken of an airplane. Now, there are airplanes all over all of the time. I want a good photograph of an airplane where I can read the tail number. That's what I want. And I don't want you to sit outside with your camera waiting for it to happen. You can carry your camera with you, but you need to be going about your day. And when you happen to see an airplane, I want you to get a good photograph of that airplane. It's almost impossible. They can't do this with airplanes. I live 10 miles from an airport. The planes are flying right over my house. That's hard to do. It's hard to take my iPhone out and try to get a picture of that airplane so that I can see the tail. I've tried that myself just to see how easy is this to do, and you know, trying to answer that question as to why there aren't more photographs of UFOs. And scientists ask this all the time, but surprisingly, the scientists have not done the experiment. They've not tried this themselves. You have to try it. and you'll see why it's not common. Now, that being said, it does happen. People do get photographs of UFOs, and sometimes multiple people get photographs of the same UFO. I think 2 years ago in Houston, May of, was it 2000, maybe 3 years, 2019 or something, maybe 2018 in Houston, there was a large disc observed, and multiple people, I think that it was seen by over 100 people across the city, but I think that about 30 people had gotten photos of this thing from multiple angles. And that was in the news for a day and then disappeared, right? And so I don't know what happened. It would be interesting to, I should talk to some of the guys from SCU. They probably know about this, but it would be interesting to see if you could collect those images and where they were taken, and find out where they were taken. And
just jump a little aside here. The SCU, for those who don't know, is a scientific coalition of UAP studies. So there are scientists that are taking this seriously, and you're part of that coalition that wants to study UAP or UFO. So can you say a little about that?
Certainly, yeah. It's a coalition of scientists who are interested in studying UAPs or UFOs. And it was started by Rich Hoffman and Robert Powell. They formed SCU, I think it was just a few months before Lou Elizondo and came out with and the New York Times came out with the story about the ATIP program. If I remember right, they started SCU that fall in September, and then the story about the ATIP program was released, in December. So not at this point, there are over 100 members of SCU. They're all STEM professionals, science, technology, and engineering, and math. And I think there are over 65 PhDs, working together at this point. They have multiple projects that the society supports, and at this point mainly looking at things like statistics. So we're looking at underwater sightings of USOs, these things underwater, and where do they happen, and can we find hotspots this way? Or another project I know is they're looking at any correlations between sizes of UFOs and shapes, and trying to get information this way from statistics. So that's one activity that's happening. There are also a number of groups who are actively trying to collect their own data on UFOs. And so I belong to UAPX as well. That was started by Kevin Day and Gary Voorhees. They were both present during the Nimitz encounters and in 2004. And they started UAPX to basically go out and try to collect our own data on these UFOs to try to figure out what they are. And so, and from there, I know from Kevin's perspective, Kevin Day is very concerned about air safety. Those were the issues that, he was concerned about when he was detecting these things on radar on the USS Princeton. And so he's very aware of air safety issues.
So far from the reports that we have been given from the military, there haven't been any collisions that we know of, that these craft have avoided us at the last minute, moved out of the way. They seem to be far more maneuverable than we are, so they seem to get out of the way of our clumsy lumbering vehicles. But have you heard of any accidents unofficially?
I don't know of any collisions. I know that there have been planes lost, but I think no one knows what's happened there. There was was it Mantell in the 1940s or so? He was flying a P-51 Mustang, and they were chasing UFO, and he was lost. They think that he went too high and probably blacked out from lack of oxygen. I know there was 2 pilots lost. They launched out of Truax in Lake Superior, Wisconsin, and they were lost chasing a UFO. And it's not, I don't think their plane was ever recovered. So I don't think that anybody knows what happened there.
The Fred Valentich case here in Melbourne, actually.
Right, that's
Yeah.
right. Yeah.
Famous case.
And the Iranians, and I know the Iranians lost in, it would be an F-14. I don't know if it, yeah, I don't remember F-14 or F-15. I think it was probably F-14 that they lost chasing a UFO. But that might have been lost during takeoff, I think. It might not have been because of the UFO. So
there certainly should be a protocol as rather than pretend that they don't exist, to ask pilots to watch out for them. And this is the protocol for when approaching or being approached by one of these craft to
exactly. And I think you'd think that would be more of a concern. There was also the case, was this 2006 in Chicago O'Hare Airport. There was a large disc hovering over gate C7, United Gate C17, I think it was, hovering over the gate on the airport. Now that's restricted airspace. That's a problem. And there's a nice video somewhere on YouTube of the news report, and they were actually they played some of the communications between the radio the towers and the pilots coming in, but they were changing which runways planes were taking off of, and they'd say, you're going to take off from this runway, be careful of the UFO, and it's striking because there was, as far as anyone knows, as far as I know, there was no FAA investigation into what the UFO was and what it was doing there. So
I didn't know that
somebody was able to hover a large craft over a busy airport and nothing happened. Well, that's kind of surprising.
Yeah, from what I remember of what has reached here is that it was some sort of another prosaic explanation. A hole punch cloud phenomenon was mentioned, that there was basically,
except the hole punch happened after the thing left. So,
the Jedi mind trick. Nothing to see here.
Nothing to see here. Yeah, and you had asked about astronomers and their now the going back to that a bit. The fact is that most UFOs have prosaic explanations. Most are misidentifications or unidentifications of objects that are well known. Many times it's the planet Venus, many times it's Jupiter, many times it could be a sundog, it could be some electrical activity, ball lightning, sprites, elves, the things that are way up in the upper atmosphere. Ball lightning is an interesting one because there's a taboo in physics about studying ball lightning. So I'm usually quite amused when I hear a physicist just, off the cuff say, oh, it's probably just ball lightning, like as if ball lightning is well understood or something. Ball lightning is not well understood. It's not understood in what conditions it develops. How it evolves isn't understood. And people who study it have problems getting their papers published.
So it could be a UAP.
Yeah, so the ball lightning excuse, I think, is always a fantastic one, because that's another thing we're not allowed to look at and talk about. But if you think about it, it kind of surprises me that astronomers step up as the scientific experts in this field. They clearly haven't studied UFOs, and in fact, they are experts in a handful of the prosaic explanations for some of the UFOs. So of course they're going to gravitate toward those explanations. They don't have experience studying the weird things, the things that aren't explained, the anomalous objects, the ones that are clearly craft. They don't have. Why are you talking to an astronomer about something that was identified as a craft, but the craft has unusual capabilities? You can talk to an aeronautical engineer if you're going to talk to somebody about craft.
It's the assumption amongst journalists it's the assumption amongst journalists that they must be ET. Therefore, that is the domain of an astrophysicist. It's because it's from out there. It's not us. It's alien.
Astrophysicists don't know anything about life elsewhere. Nobody knows anything about life elsewhere at this point. So we're all ignorant about this. Yeah. So I find that funny, and then it's hard to now. I have some sympathy, being, a professor of physics, and I teach astronomy. I have some sympathy toward their initial responses, and that is one of the things that you have to do in astronomy that is annoying is you have to deal with this whole problem of astrology versus astronomy. We are now in the 2020s, and there still are people who believe in astrology, which is surprising. Now, astrology is a pseudoscience. It is not real. The position of Jupiter is not going to tell you when you're going to meet your true love. This isn't reasonable. So in astronomy, you have to, we learn how, when we teach astronomy or learn how to teach astronomy, we learn really quickly through experience that you have to shut these ideas down pretty quickly and make it clear to the students that these are very different things. Astrology is often confused with astronomy, and especially because the signs of the zodiac are representative of constellations in the sky where the sun happens to be at that time of year. So there are relationships between facts, but they are not the same thing. So we're very used to having to shut down pseudoscientific beliefs in astronomy. And so we all, and teaching astronomy, we all you learn to appreciate the importance of that, because to get the students to make any progress in understanding what's actually going on, you have to get past that point. So I do have some sympathy for professional astronomers when they are, confronted with these ideas, but especially with UFOs and UAPs. But the problem is that the first thing you need to do before you speak professionally on a topic is to do your homework. So unless you're an expert on UFOs and you've been studying UFOs for some period of time, you really shouldn't say anything about them. One thing you can certainly say most of them have a prosaic explanation, and these are some of the explanations that sometimes hold. But they really, it surprised me, especially more recently. You've got many astronomers are jumping out there and willing to put themselves out there and make professional statements about something they haven't studied, which is really dangerous. And then in addition to that, they are unwilling to say, I don't know. So if asked of a specific case, what do you think this thing was? The answer should be, I don't know. You can say very often, it's something like this, this, or this. But if they haven't read the details of the case and looked at all the details, then they really aren't in a position to offer an explanation of what it is. Oh, it could have been ball lightning. It could have been my grandma too. No, it can't. No, it isn't. It isn't ball lightning. You didn't study the case, and this assumption that especially with the naval sightings, that these are very possibly some natural phenomena. No, the pilots are saying these things are moving faster than our planes can travel. They're accelerating far faster than we can imagine accelerating. And those statements made by the pilots are borne out by the videos and borne out by the radar data. Now, it's easy to say, and this has also been said, well, there's very possible there's been spoofing, radar spoofing or spoofing with the electro-optics. So you could imagine some drones from some foreign adversary, and they're spoofing, the electronics of these planes and ships. And yeah, it's easy to say that off the cuff. And I'm often surprised at how willingly some people jump into that explanation, because such spoofing or jamming radar and things like that, that's an act of war. Several of the pilots have pointed that out at this point. And and we are now in a delicate situation, because if we have lawmakers who believe that it's spoofing, doesn't matter what it actually is, if they believe that's what it is, we are now in a position where they may decide, well, we need to do something about that before we get a surprise attack. And the next thing you know, we're going to war with somebody because somebody thought that that was their plane, their drone or something. This is what was Stanislav Petrov, the Russian gentleman who stopped nuclear war because of a mistake like that made by the Soviets. We're going to end up in a situation like that if we're not careful. So these things have to be studied. They have to be studied now and carefully, and we have to be cooperating with other people because we don't want to make a mistake like this. It would be a shame. The problem was, there's several problems with spoofing. One is that we have collectively as a culture have known about these things since the 1940s. There were no drones spoofing these things in the 1940s. There were no foreign adversaries with drones, who had these capabilities in the 1940s. So those explanations would be fine if it was a new phenomenon. It's not a new phenomenon. We've been seeing these things for 3/4 of a century. And what I think a lot of people don't realize, because people really haven't looked into this, is that these things were well known well before that. One of the first people to study UFOs was Charles Fort, and he's from Albany, from the city actually, and he's had written books about UFOs and other weird things in the 1920s. So these things had been well observed at that point. There are accounts going back easily into the 1800s and well back into the 1700s, many accounts of which were published in astronomy journals at the time because they were thought to be astronomical phenomena. So yes, some of those were probably meteorites, but not all of them. There's several from the 1800s which are interesting, having to do with UFOs seen at sea, large discs coming out of the water next to a ship. There's a case from the 1860s where you had a large disc come out of the water next to the ship, hovered there for about 10 minutes, and then took off into the sky, shot up into the clouds. There were several from the Persian Gulf, and it's one from off the coast of China that I know of. All three of those were from the 1800s.
Okay.
So there are a number of well-documented cases which describe not exactly, but very similar phenomena, things that are described now. I actually have not encountered a lot of resistance from others. My colleagues here at UAlbany have been very supportive, which is nice. When I first wrote my opinion piece for the conversation where I stated that these things should be studied, I received a large number of emails and regular mail from people. The only people who were upset and disagreed with what I said were typically creationists who had a hard time believing that there were other intelligent beings out there. I sure hope there are, because humans aren't always that intelligent. But the thing that really surprised me was the number of scientists who wrote me congratulating, and I still get emails like this pretty much one a day at this point, of some a PhD scientist emailing me and saying, "Oh, I watched this interview with you, and you talked so frankly about this, and it was really refreshing." And I had a number of people say, "Yeah, you're right. These things should be studied." Or more surprisingly, some people said, "I've been studying them in secret. I have photos of things like this, or I do this." Or people would say, "I would like to study them. If you know how to study them and you want to work together, let's do that." So I had gotten a large number of emails from people who were actually interested. That was very refreshing. I was glad to see that, because when I wrote that article, I'll be honest, I was terrified. I had no idea how I imagined everything was just going to go south. While some scientists are interested, there still is a large number who are, really do believe it's rubbish. I mean, and in
Oh,
all
okay.
fairness, we've been taught that since we were kids,
Mhm.
um, all of us. So we've heard this our whole lives that this is rubbish, and heard it over and over and over again. Yeah, it's Venus, it's swamp gas, it's Jupiter. Well, no, not always. And there are a small number of cases where that are interesting, that are really interesting. And these sightings, some of these interesting cases actually go way back. A disc coming out of the water next to your ship and hovering next to it and then taking off. That's not Jupiter. That's not what Jupiter does. And and so it's not, there isn't always a prosaic explanation, and it's that small percentage that we are now interested in studying. And it's extremely difficult to study any phenomena that's rare, because you have to sit around and wait for it to happen, to collect any data, because you need some kind of repeatability, to be able to make sure that your inferences are reasonable. The other thing to realize, with the whole spoofing thing, or that it's, the claim that, oh, I'm sure they're just American secret craft and the Air Force was playing with the Navy or something. I've heard a lot of things like this.
Mhm.
What people don't realize, you haven't really read these reports, is that the so ships like the USS Roosevelt had encountered these objects off the coast of Virginia. And in fact, that's where some of those videos were recorded. What the issue was, that these, while they were having near daily encounters there, they then were deployed to the Persian Gulf, where they were engaged in military action in Syria. So you've got planes leaving the aircraft carrier, flying across the Persian Gulf to Syria, and they're encountering UFOs over the Persian Gulf on their way to Syria. And you can't have that situation. You can't have a pilot, as I was told by one of the people from ATIP. They said, you've got a pilot on his way to Syria, and the next thing you know, this thing comes flying at them at several thousand miles an hour, does a barrel roll around the cockpit and takes off. And now this pilot is shaken and and has to go into combat in that state. And that's not the state you want your pilots to be in going into combat. That's dangerous. And if that was an American craft, that would be treasonous. And if it was a foreign adversary, that's an act of war. So you can't just easily say, oh, this is nonsense, or it must have been this, or must have been that. No, it's something different. And we really have to accept that and then move on and figure out what these things are before there is an accident, or before there is a mistaken identity. The Iranians had problems with these hanging out, nuclear power plants, and they called them CIA drones. There's an article in Forbes magazine about that. So if you have the Iranian government believing that these things belong to the CIA and they don't, then now we have another potential conflict, and that's really untenable. So it's really irresponsible at this point for scientists who don't know what they're talking about, who haven't done their homework, to come out and say it's got to just be this. They
Uh,
don't realize what's at stake, and they don't realize that they're not keeping in mind that when you make a professional statement, you have to be professional about it. You have to do your homework. You have to know what you're talking about.
a recent comment was that the US had hardware problems. So thousands of sightings cannot be attributed to hardware
Yeah,
problems.
well, if there are, there's a whole. If that's the issue, if you're going to throw that one off the cuff, then then we should be even more concerned in another direction. I mean, then we've got a whole other set of problems to worry about. None of those that's class of prosaic explanations are trivial. Those are potentially, we might, I don't even call them prosaic explanations. Those are dangerous explanations, and that would indicate that we have a real problem on our hands that we're not addressing because we don't know what it is and we're not able to identify it. That's a whole
Uh,
different issue.
is that not insulting to the personnel who are developing the hardware and those that operate it?
Well, horribly so, yes, and it's insulting to the pilots as well, and the naval officers who had to deal with the safety issues. In
Mm.
fact, there was an article recently about how, you know, how some of these military personnel are demanding an apology. A lot of them were ridiculed for, you know, saying that they encountered these things or citing these things, and they're demanding an apology, and I think that they should get that apology.
Why do you
Um,
think the public are being fed such bullshit from people who have no knowledge, although they are scientists, that they have no knowledge or expertise in this area? Why are we fed such bullshit?
well, I don't. Why do we? I didn't quite catch that last part of the
Oh, why
question.
are we
Why,
being
what?
fed such bullshit?
Yeah, I don't know why we put up with these bizarre explanations. One popular person is Mick West, who's has, you know, blog posts about how these things are nonsensical. Well, it's not compare. You can't. And I've actually had, you know, we had there. I've had astronomers actually talk about the research paper that we published, peer-reviewed publication on the speeds and accelerations of these things, and compared that to a blog post. Scientists should not be comparing peer-reviewed scientific work to blog posts. Um, that's unprofessional as well. And I think I mentioned the go fast. I didn't say the weird thing about it. Yeah, it's not clear how fast that thing's going because you don't know how big it is or how far away it is. You do know one thing. If you look on the lower left-hand corner of that video, it says BLK at the bottom. That means black. Black things are hot, is what that means.
Mhm.
White things are cold. That object is cold. It is colder than the sea surface. So
Hmm.
seagulls are not cold. Seagulls are warm-blooded. They're warm. That's it. Simple. These are, you know, so people are saying, oh, it's simple. It's this, this, this. No, you're not actually thinking is the problem. It's simple. It's not a seagull. That's demonstrated immediately in that video. It's not a seagull. Plus, our equipment runs hot. Drones run hot. They put out heat. And this is common. Now, what we found with UAPX is we've been actually watching the skies with our own FLIR cameras. David Mason from UAPX has been able to supply us with a number of FLIR cameras that we've been using, and he has found, you know, we've recorded videos of UAPs. We have one object is following a jet airplane. The jet airplane is hot, as they should be. It's a machine. It's thermodynamics. The UAP following it is really cold. It is 60 degrees below zero, and it's shaped like a three-leaf clover. It does not at all look like the airplane. So we know it's not an airplane. And thermodynamically, it's different than an airplane. So we have additional information about the physics of these things now that we're actually looking, and we're starting to learn about them. So some UAPs are cold, which is really anomalous. And you're not going to explain that away easily with the Chinese drone or something. The idea that, oh, these things all have prosaic explanations. Some of them are identified as craft. We know that they're craft. We know they're metallic. That's known. One good example of this is from Gordon Cooper, astronaut Gordon Cooper.
Mm.
In the 1950s, he was at Edwards Air Force Base, and they were setting up cinematic theodolites to record the landing of a test aircraft. So the theodolites are basically telescopes with cameras, and cinematic means that it's able to take several frames a second or a frame per second. So they were set up to actually film the landing of a test experimental aircraft. And while they were setting this up, a saucer flew over the airfield and landed about 50 yards away from the crew. And so they went out there with their equipment and they photographed this saucer. So the saucer landed, extended three little legs, landed on the lake bed floor, and it's a dry lake bed is where the tests were at Edwards Air Force Base, and they photographed it. and they brought his crew brought the photographs, brought the film in to him. They had it developed, and Gordon Cooper, astronaut Gordon Cooper, contacted his superiors in Washington and asked what they wanted to do with it. And he was ordered not to look at it, but to package it up, and that there would be a courier by in an hour or so to pick it up. And there was. And so he sent it off to Washington and never saw it again. He had a chance to hold it up and look at it, and he says there were good photographs of a UFO. And so that thing is not ball lightning. It's not a seagull. It's a metallic craft. And so we have at least one incidence of one of these things. And that happened before Gordon Cooper flew on the Mercury and Gemini missions. So it's not like he was some crackpot who came up with this crazy thing, and then, and then the government thought, well, he's a crackpot, we can't send him into space. No, they sent the best and brightest into space. Gordon Cooper was well respected. And so there's another case. You've got to look at these cases carefully, because the interesting ones are small in number. It's a low signal to noise. So you have to study it carefully to find the handful of cases that are compelling and interesting and informative. And that's what a lot of scientists aren't doing, especially the ones who are so willing to just, say, oh, it's got to be a bug, or who knows, whatever.
Do you see that now that the Senate report is out, that this will change, and the Cometa report as well in France? Do you think that this is going to change?
I don't know what's going to happen next. The report from the DNI is really not very, the public version, or the preliminary summary is not very informative. They say there's a handful of cases, they don't know what they are. They can't rule, of course they can't rule out extraterrestrials, they're not going to be able to. And they just leave it at that. So we're just hanging, we still don't know what these things are. Probably the best thing the report says is that these things should be studied. They should set up some kind of program or some kind of apparatus to study these things. And that's probably the most important, useful thing. What is potentially more interesting is that the French GAIPAN committee, the French government has put out a larger report. Their summary was twice as long as ours, but their public report, their report's not classified, so it's a 377-page report. The downside, it's in French, so most Americans won't be reading it, but it's been made public, and that's probably going to be a lot more informative.
Okay.
I've seen some snippets of it. I have a copy of the report, and I don't speak a lot of French, so it'll take me some effort, but I've read bits of it and picked out some interesting parts. So
I have a French colleague here who would be able to read it and translate it. So I'd love to get a copy.
So I think some of that I can send you a copy of it. Yeah.
Oh, thank you.
So
it's great.
But yeah, so I think things are still changing, and and countries, not just America's been dealing with several other countries have as well. And I think that it's now, the dam is broken, and you do have scientists studying this openly at this point. You have, several governments saying, yeah, this really ought to be studied. And I think that the seriousness of the situation is starting to come to light. So I think things will change.
Okay, that's good to hear. Very reassuring. Is there anything else that you'd like to share with us, Kevin? Have we covered? I think we've covered a lot of ground.
We covered everything I know at this point.
How about a summary? What is it that we do know of the last 70 years? What is it that, in the world of science at least, I'm sure the military know a lot more, but what is it that we do know about the UAP phenomenon?
Well, we do know some things about their speeds and accelerations. That's what our paper was focused on. And there were still a number of cases that we could have covered but didn't, that the results are pretty much the same. So we looked at, in that research paper, we looked at several well-known cases. First was with a Navy case with Graham Bethune, 1951, I believe, where off the coast of Newfoundland, a large disk came up from the ocean up to his altitude in a very short period of time. I don't remember the exact number, some on the order of a second or two, and and hovered in front of their plane or around their plane for some time and then took off. And they estimated the speed that it left with at about 1,500 miles an hour. It was actually picked up by radar from Newfoundland, and they verified that that was about the speed of the object. So in 1951, 1,500 miles an hour breaks the speed records. So there were no craft that people had at that point in time which had those speeds. We then looked at the Japanese airline case over Anchorage, Alaska, 1986, where Japanese 747 was followed by several UFOs for about 40 minutes. And these were picked up on military height finding radar. And the large UFO was estimated by the pilot to be about the size of 3 or 4 747s in length, basically the size of an aircraft carrier. And at one point it was so big he couldn't see out of the front windscreen. And the object in the radar, the object stays about 7.5 miles away from the plane, but then with this, the radar was sweeping every 10 seconds or so, and the object would go from 1 o'clock to 6 o'clock within sweeps. So we knew that the object was making some really dramatic motions. You can get that from the radar data. So we estimated the acceleration if the object linearly accelerated over or under the plane to get to the other side, or if it went around with circular motion. And either way, you've got accelerations that are, in excess of 50 G. So 50 times the acceleration of gravity, which is very high. So imagine hovering an aircraft carrier in the first place, and then accelerating the aircraft carrier at 50 times the acceleration of gravity. These things are really, I don't think people really realize how anomalous this is. We say they're anomalous and surprising, and they think, oh, it just must be a matter of parallax or perspective. And like, not at 50 G, it's not. That's not, you've got to look at the numbers. I'm looking, and we did estimates with uncertainties, so we know how wrong the pilots would have to be for this to be reasonable. And we looked at the 2004 Nimitz case, the accelerations that Kevin Day recorded from the USS Princeton with the radar. He detected these things at 28,000 feet, dropping to sea level in 0.78 seconds. The minimum acceleration to do this would be accelerating halfway and then decelerating at the same rate the other half. That would give you a minimum acceleration. So we know what the minimum acceleration is. And this is a physics 100 level question. And in fact, there was an article of a physics class, high school physics class in Georgia. I was really pleased to see they were actually breaking down our paper, and he was having the students do the calculations themselves. Yeah, high school students can do those calculations. Mm. And it surprises me that physicists and astronomers aren't doing the calculations. Instead, they're coming out with their off-the-cuff explanations, but none of them have done the calculation that a high school student could have done. That's shameful as well. So you do that calculation, you find that object had to accelerate at a rate of about 5,700 times the acceleration of gravity, which is crazy. And so what would happen to somebody in that craft if you were accelerating at let's say we're accelerating at 1,000 times the acceleration of gravity. So if you take the upper half of my body and say, all right, let's say my upper half of my body weighs 100 pounds. Just use nice round numbers here. And now we accelerate upward at 1,000 times the acceleration of gravity. That means that this 100 pounds is going to feel like 100,000 pounds. Do you know what would happen if you put 100,000 pounds on your head?
You'd probably turn into mincemeat.
No, that's right. Yeah, you're going to be jelly on the floor. There's no way you're surviving. Nothing, there's no flight suit in the world that's going to protect you from this. That acceleration is totally unreasonable. Yet, and at that acceleration, you can then figure out what was the top speed at the midpoint. So it had to accelerate to a top speed, and then it had to slow down to stop. The midpoint speed turns out to be about 35,000 miles an hour. So this thing is moving at about 60 times the speed of sound at the midpoint, which is crazy. 35,000 miles an hour is about how fast our probe to Pluto, the New Horizons probe, which is now going to the Kuiper Belt, that probe to Pluto is traveling at 35,000 miles an hour. This UAP accelerated from 0 vertical speed to 35,000 miles an hour in half of 0.78 seconds. So what is that? 0.39 seconds or something like that, right? In less than a half a second, it accelerated from 0 to the speed at which our probe to Pluto was traveling. That's how anomalous these things are.
It's mind-boggling.
So then you are confronted with another question that scientists ask. They say, why is it everybody assumes these things are spaceships? The answer is simple, because these things travel as fast as spaceships do. That's it. It doesn't take a PhD. This isn't rocket science. This is easy to figure out.
Assuming that we're witnessing them traveling at such horrendous speeds, it's nothing to them to travel to another part of our galaxy, you're saying?
Oh, not at all. Yeah, at 100 G acceleration halfway and then 100 G slowing down, you can get from one side of the galaxy to the other in 3 months. It's a 3-month. If you had a race, let's say we're going to send our next probe to Mars. It's going to take 9 months to get there. And one of these UAPs is going to take off at 100 G, not even 1,000 G, 100 G, order of magnitude slower acceleration to the other side of the galaxy. According to their clocks, they'll make it to the other side of the galaxy before our craft gets to Mars. These things are not comparable at all. And it's not a matter of any country leapfrogging another country. These are multiple breakthroughs. There are multiple breakthroughs involved here, not just one. And I don't think people appreciate, I don't think people really appreciate the scale of the difference here. And the difference is really, really amazing, really dramatic.
They're not 100 years ahead of us, maybe not 1,000, maybe 1,000,000 years ahead of us. What do you think?
I don't know. I personally don't try to use those time scales because technology doesn't really go in a linear fashion all of the time. Breakthroughs happen randomly in some cases. So, but you're right. It's multiple breakthroughs. They're ahead of us in multiple ways, and I don't think that that's well appreciated yet. Once there's more information about these things out there, I think we're all going to be pretty amazed at these objects. And I think that, there was, some talk about, thank goodness they're not hostile, because if they were, we'd be in trouble. I think that a lot of people have the idea of the movie Independence Day, that we'd be fighting something like that. No, these craft the Independence Day craft were not that much different than our airplanes. These things are nothing like our airplanes. They are so much faster. We couldn't begin to move at these speeds or do anything with these objects. You can't shoot them with a bullet. Bullets only travel 1,000 miles an hour. Bullets are slow.
Can we shoot them with a missile?
Missiles can't accelerate like that either. Missiles can retain their ability to maneuver up to about 35 times the acceleration of gravity. But their airframes start breaking around 60 times the acceleration of gravity. These things, in all of the cases that we looked at in that paper, they were all moving faster than a missile can accelerate. Yeah.
So with David Fravor, they anticipated, they knew that he was going to be back at his cap point at a particular time and it had appeared there. So clearly they're, I don't know, not clearly, but what are your thoughts about that they
That
are
is
masters
weird.
of time, or they, yeah, that's another high strangeness thing, isn't it?
That's a strange thing. I mean, the first thought is that that's a good argument for it being some kind of American experimental craft, right? If it was an experimental craft that the Americans made, then they wouldn't be able to figure out where the cap point was and get there. So that is a good that would be reasonable there. The problem is that it can't possibly be an experimental American craft for all the other reasons we gave, right? So that really doesn't hold water. The only thing you're left with, if these are, you know, from a non-human intelligence, which is really all you're left with once you go through all of these details, is that clearly they were able to intercept the communications and understand them, right? So it means they had to be able to decrypt the code, and then they had to understand what was being transmitted. So I think that's basically what had to have happened. The other possibility, and I don't know the details, I'd have to talk to Kevin Day about this, is that if they had been using the same cap point for several, for several days or something during their tests, then it's possible that they were just observed and it was assumed they were going to go there. So that's another possibility, but I'd have to ask Kevin Day what the situation was.
I don't know where I got this impression. I thought that the cap point wasn't communicated over any sort of system.
That was my impression too. My impression was that I think that was it wasn't widely known. So
yeah, this is what amazed them, that there was no way that anything could be eavesdropping. I guess that's why David Fravor was so astounded, because it was between him and the person who communicated the point to him, and he felt that they had read his mind somehow, the entities.
Yeah, I'll have to ask Kevin about that. That's interesting. And get the details. The details matter in these stories. I mean, this is where we don't have a lot of information from the electro-optics, and so what really is important are the accounts of the pilots and the people involved.
Yeah, and
that's all the information you have to work with, so you have to be sure to get that information and make sure it's correct.
As a physicist, I guess you're not really examining the personal interactions with entities much, but do you have any thoughts about that?
Those are very bizarre. Yeah, all of that is very strange and very unnerving. Like I think we talked about that before, the telepathic aspects. That's very hard to imagine, and it's very hard for me to get my head around. And in fact, that's something that I would easily discount if it wasn't so prevalent. The difficulty there is that, having studied neuroscience, having worked in neuroscience, everybody's brain is a little bit different. We're not identical. So interacting with my brain, interfacing with my brain is not going to work. If I made a machine that, brain computer interface, and I got it working on myself, I wouldn't be able to put it on your head and make it work. We're that different. So how could anything telepathically communicate? I can't imagine it would be biological, because why would those things evolve to be able to telepathically communicate with humans? I wouldn't imagine that they'd be that similar. So when I think about that, I think it has to be a technology. But I don't know how that technology could even work either. So I'm really at a loss there. That I think is fascinating, and I I'm not sure I can easily discount those accounts. So I'm left wondering if there's something we have yet to learn.
So
The
given that the
yeah,
civilizations, it makes no difference to them whether they leave somebody behind for 300 million years or not. Could it be an artificial intelligence robotic civilization, not a biological one?
yeah, well, they could. Yeah, that definitely is possible. I mean, we don't know what they're like at all, and I think that's why the phrase non-human intelligence is probably the smartest one to use at this point. It's not clear that they're biological and or what they are at all, and um, so that's definitely a possibility. The abduction phenomena is also very weird and creepy. Um, the
And the cattle mutilations also.
Oh yeah, I don't. Yeah, those. Yeah, that is very strange too. The so the abduction phenomena is strange. You know, of course, popular culture talks about anal probes all of the time. From what I understand, that isn't as common as the taking eggs and sperm, which I find to be a lot more creepy than, than anything else. Um,
I think Whitley Strieber, when I read one of his books recently, the purpose of his experience was to stimulate the production of sperm, and this is why he had that experience. It was,
uh,
and it's not. We focus on that it happened to him and it was horrible and creepy and invasive, but he talks about what the purpose of it was. So it was part of the same thing in that
right.
that was an extraction method, an extraction of genetic material that they apparently wanted.
Yeah, so
Yeah.
so now you're left with a bunch of questions. What are they doing with all this eggs and sperm, and why? And so my first question is, well, my first guess is maybe they're doing experiments, right?
Mm.
The problem with the experiment hypothesis is that the number of abductions or claimed abductions is way too high to warrant an experiment. Um, you don't need that many people to do an experiment on. I would say maybe 1,000 would be sufficient for most experiments. So why so many abductions? So one answer could be not all of the abductions are real. Well, that would be strange because the accounts are so similar, and there are many similarities that not aren't widely known, um, that are shared amongst people. So that also makes it difficult to discount all of those. So if they're not doing experiments, then what are they doing? And that I don't wouldn't have a good answer for. Yeah, this is the thing that I feel is certain is that we're going to learn a lot of strange things, and we're in for a heck of a ride this century. Beginning of the last century had some big breakthroughs. I mean, we had
Mm.
the relativity and quantum mechanics, and we're now able to talk to each other, on the computer screen because of quantum mechanics, right? So our
Yes.
knowledge of quantum mechanics. So that dramatically changed our culture, and I think we're in for another big change.
Yes. Very interesting times. Kevin, you've been very generous with your time. I think we've covered everything we possibly can.
I
And
think so.
thank
Thank
you
you very
so
much.
much. It's been wonderful to chat and look forward to talking to you another day.
Thank you. Yes, me too. Thank you for having me.
My pleasure.